want to end up doing in this unit is factoring. This is kind of the main idea of this unit. So we want to factor. So factoring really means that we want to put them into rectangular shapes. So we want to be able to, using the tile, show the factor pairs of 6 plus 2x. So we can factor this without algebra tiles, but what does this look like with algebra tiles? So if I were to factor this, factoring means I find a greatest common factor first. That's always the first thing I do when I factor. So the greatest common factor, or the divisor that will divide into both those, is 2. So I can factor this into 2 times 3 plus x. Okay, so this would represent my area, and this would represent length and width. So what does that look like? Well, if I were to show my algebra tiles here, I have 2 x's. I'm going to draw my 2 x's in like this. And my ones tiles, I can't line up my ones tiles with an edge of x. I can only line up my ones tiles with the ones edge. Okay, so this is the shorter edge is my ones edge, and I need to be able to fit 6 of them, and I need to keep this in a rectangular shape. Well, the nice thing is this is in groups of 2, as I can see here, it's groups of 2, and I could put my 6 into groups of 2. Like this. So I've put my x's into groups of 2, and I've put my 1's into groups of 2. Well, groups of things are multiplication or factoring, and that means I can show this as a product of length of 2, a length of 2 along here, and a width of along here, I'll do along the bottom. This along here is going to be x, 1x, plus 3 1's. Okay, because I have my x here, 1, 1, 1. There's 3 1's, so x plus 3 1's. And it shows me, with algebra tiles, my factored form of length of 2, width of x plus 3. And it's the same as my factored form. And again, this represents my area. And this is my length times width. Okay, so what are the factor pairs for 8x minus 4? Well, I can put this into groups of 4 and groups of 2. Okay, so I'm going to do 2 different factors here. So I'm going to do it in groups of 2. So I factor the 2 out. So it becomes 4x minus 2. And in a different color over here, I'm going to do a different one. I can do it in groups of 4. So 2x minus 1. Okay, so what does this look like when I rearrange these two into rectangles? I can rearrange this into groups of 2. So I'm going to have 4 x's Okay, so I'm going to shade these ones in. And I'm going to have 2 groups of 4x minus 2. So that's one group of 4x minus 2, and then I have 2 groups of 4x minus 2. Okay, so along this we have 2. Along here we have the edge length of 4x's minus 2. And it's important to recognize, to label the length differently here. This is four lengths that are different than these 2 lengths here. So 2x minus 1, I have 4 groups of those. So I'm going to show my 2x minus 1. Okay, and then I'm going to end up with 4 groups of them. So there's 4x minus 2. This is 6x minus 3. and there's my 8x minus 4. So this product here is 8x minus 4. The length is going to be, well, if I count along the edge, this is a short edge, so those are 1s. 1, 2, 3, 4. 4 1s. Along this edge I have 1x, 2x, and a negative 1x, or sorry, negative 1. So I have 4x minus 1. So there's my, oh, sorry, this is not 4, it's going to be 1, 2. So 2x minus 1. So there's my length and width, 4 times 2x minus 1. There's my factor pairs. Here my factor pairs are 2 and 4x minus 2. My length is 2. My width is 4x minus 2. So we can do it the other way around as well. We can start with the length and width, and we can show the distributive property where we distribute into the bracket. So multiplication and subtraction, we can't do them the same, so we needed something to mix them together, and the mixing them together involves the distributive property. So we end up with 6 x's in total, and 2 groups of negative 1 means we minus 2. So we can show this in algebra tiles by showing the length and width. So I'm just going to maybe represent the length and width with algebra tiles. So I can have 2 groups. Okay, so I'm going to have 2 groups of 1s. It's going to be along, I'll put them along the vertical. And then 3x minus 1, well, I can show 3 x's along the outside here. 3. So this, what I'm drawing here is not the area. I just kind of made those lines there to distinguish the length from the area. So this is 3x minus 1 along the width, 2 1s along the length. And the shape that I'm going to generate is going to be an x here, an x here, an x here, and everything on the inside. Maybe I'll do this in a different color so that we can see that this is not the same as the length and width. So we have an area of x, an area of x, an area of x, and an area of negative 1. And we have 2 rows of them, or 2 groups of them. Okay, so the length and width is going to be 2 1s, 3x minus 1, and the area is going to be 6 x's and negative 2 1s. Okay, so we can start from the area and work out the length and width, or in this case here we started off with the length and width, and then we showed that the product, or the area generated by that length and width, is going to be this area of 6x minus 2.